aerospace projects typically are negative for a long time, and then gradually they start to bring revenue to the company. And one of the main points of this picture is really to show that when we talk about a product, from when this is what I learned right in the beginning, is that the product starts from an idea, a vision, a concept, and understanding customer requirements, and that data needs to be maintained right from the very first point in an aerospace project, all the way through to actually starting the development of an aerospace aircraft. Let's talk about an aircraft, it's easier. And then we typically burn money all through research and development at great bucket loads until we get to a situation where we actually start to produce something and deliver it. And then we start to turn this negative value into a positive trend. And gradually we start to get to this point where we've got back to even. And this can take, in the aerospace industry, a decade. And so all upfront, we're throwing money away, and we hope for revenue in the future. Once the aircraft is actually there, then we need to maintain the aircraft all through its life cycle. And this means certain type of spare parts sold to it and installed to it, certain type of maintenance activities put on the aircraft. So the in-service support becomes vital. And this means that to understand what has been designed, what has been actually built, and then at the end of the day, what needs to be maintained have to be tied together. And this is really what PLM is trying to do. That if we start on an aircraft project, we understand the requirements and understand the digital definition of the product and the digital definition how the product is made to when it's actually delivered. And then once it's delivered, how do we maintain that aircraft over its life cycle, and that aircraft program, that it's financially viable. So there's actually some profit in it. So this was a picture. This is where I bumped into PLM, or it bumped into me. So if we move forward, then actually, so if we think, I'll go through a few definitions. So if we talk about PLM as a concept and what is PLM, try to give it a definition. There's many different definitions, but I think everybody is starting to come around to one overall common definition. So it's regarded nowadays as a strategic concept. It's a business approach, how you manage your products. And it also safeguards the intellectual properties of a product over the complete life cycle. So what has been designed is important, but also what is maintained, what is your install base, that is also equally as important. And that is where many times the revenue is. And just a footnote here, my examples will be in the manufacturing business to business area. So I'm not talking about consumer goods so much, but obviously the same concepts apply there nowadays. So if we go back to the actual definition, we see, okay, so it's a strategic concept. It manages the IP of a product over its life cycle. That's one way of looking at it. The next one is that what does it include? Well, it needs to include the actual business elements that a company has to maintain this data. So a PLM typically defines the processes over the life cycle, how the product is designed, how it is manufactured, how it is then supported, how it's sold, how it's marketed, etc. And then because it's product lifecycle management is looking at the product, it typically also starts to impact on the organizational structures. So if you start to implement ways of managing a product and defining a product with real-time simulation as part of your product development process, then immediately that would be something that would be part of the PLM sphere, which you would start to define from a process level, and then you would also start to define the actual organizational structures. You would need certain competences around real-time simulation to bring that to full use. It also includes the actual methods, how you define a product, how you support the product, how you sell the product. So what is in there? There's processes, there's the organizational structure, and the actual methods, the unwritten ways of doing things. And then also there is the actual supporting IT system. So typically PLM has always had this idea of utilizing IT systems. And I would like to highlight here the information technology systems as a plural. We're not talking about one system. We're talking about a magnitude of systems over the life cycle and their integration. But at the point of it, and always one of the highlights in PLM has been the actual human factor. So the human element is involved here. And one of the drivers also, goals is also to join different areas of the company together. So it's not siloed approach where designs and sales and marketing is try to sell it, and then delivery tries to figure out what should be delivered. But to actually have a smooth running process. So all of the products, all of the company elements are connected together, and the related processes and resources have a certain place and time within delivering, maintaining, and designing the product. So this is one way of looking at what the definition of product lifecycle is, and this comes from the below mentioned person. This is just one definition that you could look at. Then if we look at closed loop product lifecycle management, another definition. So basically all this is saying is that there is a closed loop within PLM, and we come back to that a little bit later through a drawing. But the basic idea is that what is designed and once it's delivered, the information can flow back. And so what PLM is trying to do is it allows all of the actors to play a role during the complete life cycle of the product. And the idea here is really to track, manage, and control the product information, all of the information that is relevant to defining that product, and then also defining how that product comes into existence, and then how it's maintained. And the idea is that this data can be pulled out at any phase of the product life cycle. So if you're in the design phase and you need to look at certain requirements and understand how those requirements reflect on certain design decisions, selection of physical components, then you can look at it. But at the same time, you could pull out information on a actual instance, an aircraft that is operating in the field, and you could understand what was the manufacturing process, what was the sourcing process on the materials that was used to understand what this product actually is. So you have a thread of that product, and it's available digitally. Okay, so these are a few definitions, and there's plenty to choose from. So if we move on to the question is, why is PLM relevant? We've already established it's trying to join the organization together. It's trying to bring the way of defining product, way of managing the product information together, and also looking at it through the complete life cycle, when the product is on paper or in digital format to when it actually appears into the real world. So if we look at it, the way you can understand products, and typically in PLM, the product and services are at the core. And when I talk here about products, I'm not only talking about the physical products that can fall on your foot, but I'm also talking about the services that are related to them. So typically, this is one of the main aspects that need to be considered when looking at products and product lifecycle management. It's not only the physical products that we're talking about, it's the complete system. So if we look at if you can see my pointer, if we look at a simple product, at the end of the day, even with the simplest product, which is here a autoclave from Autotech, it's a physical product, but related to that, there are certain services that are integrated, like spare parts and then certain type of consultancy services, maintenance services. If we build on this basic idea that equipment is a product that has the physical and services combined. If we look at the next picture here, we have complex solutions, and this is an example of a mineral processing plant. The basic idea is that copper ore comes out of the ground, and then it's basically crushed, ground, and then crushed, ground. And then you extract the copper from the leftover remnants, and then gradually you enrich it through the process. So you finally have a certain type of copper grade that you can actually turn into electronic industry level copper boards. But the basic idea here is that here again we're talking about products that are joined together to create a system, and this system can then create different type of processes. For instance, here, if you can see my pointer, this is the grinding circuit, and then here we have a flotation circuit, and over here we have the actual filtering plant. So the idea really is that if we start from a basic product, we need to manage this product's information and the services related to it over the life cycle. But once we start to look at complex systems like a mineral processing plant, we need to look at the complete system, a set of products or equipment, their services, and then the processes that these products together do. So here we have a grinding process, here we have a flotation process, and they consist of products or equipment, and they do a certain process within this plant. So this is when we start to look at more complex solutions. And obviously the thing about here, when we take this approach, we very quickly identify this sort of asset-based services. So typically the asset exists, and then we have the maintenance, diagnostics, shutdown services, spare part that we would be delivering on these. So this is the other element of product lifecycle management is once you design this plant and it's been sold, then you have to have those services to maintain it over the life cycle. You need to know what services work for a particular plant or a particular solution. Moving on then a little bit further, then obviously we start to see nowadays this product service systems where the actual products and services are integrated. They become more and more digital. And a good example here is just a couple of, is like the Apple ecosystem. You have the end telephone, but at the end of the day, there's a digital platforms that are connected. There's the actual applications that are there that you use. And then this brings a certain product service system that is combined. The actual physical product is only one aspect. And this is bringing more complexity within the PLM area. And then finally, we get to the situation that if we have the digital, physical, and service world combined together, then obviously once we start to understand the data, we can start to build certain aspects of smart, connected, or intelligent product service systems. And this here is an example of one aerospace solution that we see the physical thing in the air, but there's a huge amount of connected back-end systems that are supporting this. And there is a certain amount of intelligence built on this to make decisions on its own or recommendations. And when we look at PLM, where it started from, we were really looking at very straightforward equipment, but as the years have gone past, more and more complex systems have occurred. And part of the reason why management was pushed forward was due to the American space program, the Apollo 13, or the Apollo space program, because they used a huge set of different type of subcontractors and contractors, and they need to make sure that the actual rockets that were being put or assembled then finally in Florida actually came together, and the parts fit together. But basically the idea here is that when we started to look at product lifecycle management, the first thing is really the question to, do we understand what products and services we're talking about? Any questions so far? Okay. If not, please just feel free to open the mic and ask. So if we establish the basic idea, okay, this is what PLM is and this is what we understand with products, and what are the main trends in manufacturing business can be seen today. So if we move forward, we can see that the extended product definition and number of product variations and technologies is increasing. So that is one aspect that is happening there. Then we also see that lifelong view of the products and businesses is becoming more important. So most companies in the manufacturing sector nowadays providing solutions are in a situation where their products have long life cycles. Aerospace example, for instance, certain aircraft will have a life cycle of 50 years. Some military projects will go on 80 years before they're removed. If we look at about a mineral processing plant, or if you look at a paper mill, they can run 20, 30 years easily. But they're not the same one that have been implemented. They are upgraded throughout the life cycle. So there's this lifelong view of the products and then the business, how the business changes and how the products need to change with that business. And the other reality is that the enterprises or companies that are in business and operating, they are being more and more networked. They're not doing everything themselves. They're dependent on different type of partnerships. So what does this then mean from the actual transitions or disruptions? So it's clear that product complexity is increasing. The previous slide already opened that up. The other reality is the observation period is extended. So it's not enough to know what you design and send to the customer. You also need to know how it's maintained in the future. And then the reality of networking is increasing. So you are more and more dependent on different suppliers that are around the world, or partners that are around the world. Good example is that in the mining technology industry, you could say 80% of the solutions delivered, of the solutions delivered, 80% of the solutions sold and delivered to the customer is from suppliers. 20% comes from the actual brand that is on the side of the equipment. The same thing applies to the aerospace industry. The aircraft industry, as an example, is so expensive to program to develop that they build alliances and split the aircraft development delivery between different partners, and Airbus is a good example of this. So if these are the actual disruptions that are happening, then what actually does it mean? Then if we look at the product complexity and the networking, it puts a requirement that we need to manage uniform product information in an increasing amount. That means that the one supplier, one department in a company cannot have unique data, product information available. It has to be manageable and it has to be uniform. You have to have a common understanding what that information is. The other area, if we look at the fact, is that the building network enterprises, and then looking at the lifelong product view, you need to unify the changes within the operating model. So if you have a company that is very heavily focused on build to order, so basically you can buy anything and you just paint, you can select red, white and blue, and then you have another company that needs a part within their solution from this company that are totally engineered to order, then there may be a problem if the customer's requirements don't fall within this product's parameters. So this is another area. And trying to match an engineering to order business to a build to order business and operate together can be challenging. So this is really what we're talking about here. So the operating models, the way things are done, do you design from scratch, or do you design based on certain pre-selected design rules, or certain catalogs influence here? Then obviously, if there's a certain extended product complexity and you have this lifelong view, change management of the extended product becomes very important. So what this really means is that if a product enters into service, then the data around that has to be managed throughout the life cycle. So if it's changed, there is a retrofit, an upgrade, or something is replaced, or if you want to replace something, you need to understand how this has been done, what you can install on a certain product and what you cannot, what a certain product has in the install base, what is its life cycle changes that have been done once it's in operations. Any questions? Okay, moving on. Yeah. Yeah. Okay. Moving on. So business potential, always important at the end of the day when we talk about product, services, or anything else in companies. So this is a picture from Saksori presentation and a leaf booklet that he's published. But I think I like the picture, and we've spoken about this quite a long period of time. So really to remember here is that when we look at capital goods products or complex solutions in business to business, like a paper mill, mineral processing plant, as an example, the actual delivery of the product, the value of it is only a fraction of the total life cycle value that is available through services. And this is why many companies today, which is pretty straight obvious really, is that that's why they're focusing on services, to actually get the money laying on the table into their bank account. So they have had a huge install basis, and now this is part of the reason why most companies have focused so much on getting this service business up and running. And this service business is really focusing on the basic sort of services that can be done, preventive maintenance. As an example, somebody goes and does preventive maintenance actions, but as we become more and more connected and digitalized, then we have these remote diagnostics. We can connect to products. We can see what's actually happening. We can make adjustments before the product breaks, or we can extend its life cycle by reducing its power, or as an example. So these here is not the point to remember every single one of this A through F points, but it's to understand that when we deliver the machine delivery and setup services, here there's a huge cash flow that happens, and it's important to understand what has been delivered. But for this this long tail to work that has been delivered, and if we understand that and we have visibility to it or connectivity to it, we can continuously offer additional services around this. So here is just to name a few. As I spoke about the preventive maintenance and the remote diagnostics in point C. So you're basically doing continuous preventive maintenance to continue to support the product's efficiency. Spare parts, consumables, they will go continuously. If you take a paper mill, there's spare parts that are needed, and there's wearables like cloths that are needed in the process to produce the paper. They have to be changed. And then obviously, as we go forward, we have these interesting things that like the digital services and optimizing the actual supply chain. So just to summarize this slide, the important fact is that the CapEx, the actual sole transactional setting up the solution is important and big, but the long tail services that are available are immense. And obviously one area here that I didn't mention, I'll come back to it later, another slide, is the actual surveys, site surveys. Services done around, for instance, the mineral processing business or mining business, that is it sensible to build a mine, to offer services to potential customers before we invest, to see is there a business case here, and help them get the financial backing to actually create a mine somewhere on the other in a remote location in the world. So I've already many times opened up the basic idea. The product focus is moving towards product service systems. So typically, most companies start with this product centricity, and they build on service and build from here. But there is a clear transitioning now happening that the products and services, the traditional services, are more and more integrated to support the product lifecycle and managing the product over that lifecycle. And also by collecting this data that has been traditionally in the office and understanding it, and then marrying it with the actual operational data, it brings up new database opportunities. Monitoring services we spoke about, but at the same time, once we get that feedback information, we can start to test how we can improve the product quicker in a digital environment. And then obviously, if we have this data-based approach, we can build the business networks easier. So what is happening really is that we are seeing that the product service systems that are being delivered today, they are more on as a market proposition to the customers, and they're adding continuously new services. So it's not so much the sale of the functions and features; it's more on the business value and sales of use that is emerging. Why this particular solution is better than another one over the complete life cycle. And then just a basic definition here that if we talk about product service systems, the move that traditional product companies have towards integrating their services is this transition of the actual products and services and the business model, and that transition is typically referred to as servitization. There are examples where companies are have come from a service background, and then they productize their services. And many big players today also need to productize their services. And when I talk about productization, I mean that the product is repeatable. You don't design everything every time for every single customer on the product or on the services or the physical products. Okay, so why is this relevant? Product service systems and business transition. This is an example here, really. If we look at it, Rolls-Royce, this is one of my favorite examples. Rolls-Royce is known for building jet engines, and they build very good and successful jet engines. And somewhere along the line, they saw or understood this reality that if they sell the jet engine at a lower price, they also have this service lifecycle revenue that they can get home. And they started to build this model in the 1980s, and they understood also that if they can collect data off of the jet engines over the period of time, they can also start to sell value to the customer, not selling the actual jet engines or the services, but offering them power by the hour, as an example. Basically meaning that if they can collect the information off of the engines, and they can put it through certain simulation models and understanding the fleet that they have, how it's being used, their design issues that need to be solved, they can start to guarantee certain type of performance values for aircraft operators like Finnair, British Aerospace, Lufthansa. And this basically was made available really with the digital and connected services. So here the idea was that if we can collect from the physical product the data and information, we can start to actually build a true digital twin. We can get the basic design data and requirement data, but can we actually build a really properly functioning digital twin of this particular engine or any engine on the side of an aircraft or on the wing of an aircraft? And by doing this and understanding this vision, they were able to then create this power by the hour idea, where they're not selling jet engines, they're not selling services on the jet engine, but they're actually selling availability of power by the hour. They are promising a certain performance for airline operators. So this is what is a clear, as an example, what is happening, what has been happening. So if we look at the PLM domain, we've been talking about a little bit about it, of being product-centric, understanding the product information over the life cycle, understanding the business processes, understanding the data, understanding the IT systems that have that data available, and then also collecting the data from the field. If we start to look at the reality is that if we can build a connected physical system to a connected virtual system that is a digital twin that also has real-time simulation and machine learning in it, and it is connected through, for instance, an IoT data platform, and we can exchange the data in real time, we start to have an opportunity to really introduce a digital twin, and that brings value to companies. So what we're basically talking about is that we can have a product in the design phase, and it's totally digital, and we understand how it behaves, and we have that data managed. And once we start to deliver those instances to the customers, we can also connect to that instance and bring the data back and understand what that data means, and build new services or offer services to one or a fleet of customers. And this is really one of the biggest changes now that you can see from PLM point of view, is that now the actual idea of understanding your product data from a manufacturer's point of view, like let's use Valmet, Autotech or Airbus as an example, it was important. But now by connecting, really having the ability to connect to the real world and bring this data back in here, we don't have static models of data structures, etc. We can actually build really operating systems. And by having that, we can test out new designs much faster. We can test out new services much faster. And if we can also put it in the environmental context of how it's being used, is it being used as an example here at the side of a harbor, becomes really more valuable. You over the life cycle, you can train people, you can design better, you can sell better, you can maintain better, you can actually understand how to manufacture and assemble products faster. So this is really what is happening if you look at this area from the PLM point of view, and how the product service systems and digital twins are really putting challenges but at the same time giving PLM a great opportunity to really come to blossom.
I have a question.
Yeah.
So basically, you're saying that at the moment, right now, the importance, the data are getting more important than the real product. I mean, yeah, the real product is important, but the data that we can gather from the usage of the product can be even more important in the long time.
It is important, yes, and the problem is, if I only talk from a PLM point of view, if I put that hat on first, collecting the data, product lifecycle management has always said that the concept has always been to manage the product information of the lifecycle. One of the main issues it's had is that once the product is delivered to the customer and the customer starts to operate it, how do you know what's happening to that product, how it's being run, what spare parts are being used, and how it's maintained? But if you have this data available and you connect back, you can offer better services to that particular customer, how he should run his products in advance. So data is really, really important. But at the same time, there's the oxymoron or the paradox. What if the product doesn't exist today? We do not have this product, and it's a complex product that needs to be delivered. How can we prove to the customer this is something they should invest in? And this is where the simulation aspects, the physical models become very important. Or if they make a decision to upgrade a plant to show how their plant would work even more efficiently in the future. Did I answer your question?
Yes, thank you.
Yeah, okay, thanks, good question. So data is important, but data is only important if you know how to use it. And the question is that if you do not have the product available, or the solution available, then you have a paradox. How do you prove to the customer or the operator that this is the best possible product? And PLM needs certain simulation elements to do this. Okay. And this is just why digital twins are important to PLM, or why digital twins are important. If we look at just these this is from Siemens, just a white paper. The pictures were quite nice, and I selected. But the basic idea really is that the regulations that are being thrown at complex products or solutions are becoming more difficult and challenging, and being able to build a digital twin of that product that is not just a structure that is a bill of materials, but is actually a simulation model becomes important. You can start to prove, can we ever, or how we will comply to this regulation. The reality of multiple variants. You need to be able to find quickly and offer different type of variants, typically in the business to business sector. How do you offer a complex solution for that particular customer need using as little redesign as possible? But the reality is there's multiple variants that need to be maintained. And then obviously this, we spoke about this already, this productivity and cost of ownership. So once the investment is being made, how do you ensure that the customer or the operator gets the most out of it, is the most productive, is continuously productive, and then also the ownership is at an acceptable level. And then the last area is this: once the equipment become more and more autonomous, it would probably be better to test them out in a virtual environment than let them run riot on a field and then see what happens. So having a digital version of the real product that is being planned offers, as an example, really good, offers good possibilities. But why is it important? There's many. This is just a few. More difficult regulations, productivity and cost ownership, designing and testing new equipment or new equipment variants or new upgrades to existing equipment is a lot easier. And then also there's multiple variants that nowadays the customization of by the mass is a trend. Okay, so this was a sort of introduction to when we talk about PLM. So what is the impact on operations? So if we take a few highlights from here, what is PLM and how does it impact enterprises? So every company has a strategy, and that strategy typically defines into a business model. They select the products and services that they will offer, the customers that they will actually attempt to get, and then also the market, and then the value proposition, why their products are the best. This is just one example of a business model. Moving on, this defines the type of business architecture that a company has. So what do we want to do is a good, and how do we do business? Do we deliver engineering to order solutions, or do we sell only from a selected catalog? The other thing is the information, etc. And this defines the product lifecycle management concept. It defines other areas like operating maintenance or customer relationship management, but we're focusing on PLM. So these business architecture or these business concepts impact your enterprise architecture. And I'll come back to so if we look at an enterprise architecture, then the PLM concept impacts the complete enterprise architecture. And what this really means is that it defines the processes and the process roles, how product is defined, how the product is sold, how it's maintained over the life cycle with suppliers and with the customer. It also defines the information architecture, what type of information you need there. And then it also defines the underlying integration technology and the IT architecture. So there is the PLM systems, there's the design systems, there's the ERPs, but then there's also the digital platforms that are connected, offering services to customers. There's the data analytics, there's the end devices. So they are connected back. And then at the end of the day, typically most companies have this continuous implementation roadmap. So when PLM is introduced as a concept, it starts from the strategy, it influences the business model, it creates its own business architecture, and then it plays around with the enterprise's architecture, the processes, the information, the integration technology, and then there's the actual implementation roadmap, how this needs to be done. One thing that was missing from here is the organization structure and roles. And this previous slide is an actually real slide used in a company years ago. The point really here is that the organization, if you take PLM, you start to introduce digital twins, you start to introduce real-time simulation, the data collected and the methods collected from there, the processes, then new roles are needed. So what develop and deploy? Business processes, as an example. I won't go through all of these. It also defines the information flow and the data that is needed. It redefines the process roles that need to be there, that are missing, and how they should interact with existing roles. There is typically organizational changes when PLM is done. And then you have the fact is that how do you build this IT architecture in-house, but how do you also open up that architecture toward the customer through IoT platforms, digital devices, digital services, as an example. And then one of the things is that there's the reality is that once you put this in place, there has to be a way that you can manage this overall new product architecture through PLM. So PLM offers the management system around it. Just moving on, if you look at it from a process point of view, this is a very high level, sort of streamlined view of it. If we look at PLM and we talk to closed loop PLM that I started in the beginning, typically you can see there's the actual phases of the marketing processes and research and development processes, and the outbound marketing processes. And they, as an example, they define the product in the portfolio. What products you design in your portfolio, what you remove from your portfolio. And this is typically the first life cycle that we're talking about, the beginning of it. The next one is really the delivery of the instance, how you market it to your customers, how you sell it to your customers, how you deliver it to your customers. And this is the actual product that is being, the instances that are delivered to the customer. And once that product is delivered to the customer, then you have the third life cycle of maintaining it, maintaining the product or the instance in operations throughout its life cycle. And this is the long tail thing that we spoke about earlier. And the point of understanding this is that each of these life cycle phases needs to be efficient, and they need to be, from their own point of view, as efficient as possible. But at the same time, PLM's role is to make sure that this life cycle view over all of these life cycle 1, life cycle 2, and life cycle 3 operates smoothly as possible, and the business processes work end to end as efficiently as possible. And the feedback loop is really that within any of these life cycle phases, we can push information upstream, but we can also collect information downstream. So this is the framework, you could say, from a process point of view. This is what PLM is looking for. And then if we look at the product aspect of it, again, that if we look at the life cycle view, we can look at it from three dimensions. One is the actual product improvements. So we improve a product in design. Here is just an example. We just increase the size of a certain product from 50 cubic meters to 70 and so on. So we have the scalability of the product aspect. The other area that we can look at also is how do we integrate in design, sales, and delivery, the actual technologies through to the actual equipment systems and product lines, and then plants to build complex systems for a delivery point of view. But at the same time, we also have the third one, which is the actual life cycle services and future opportunities. So if we deliver complex products, we need to have certain type of delivery and sales services. At the same time, we also need to have the pre-delivery services, post-delivery services, and then there's this continuous cycle of introducing new IoT-based services or digital services to the customer. So this basically is showing that the dimensions of products and services, not one line, it's three-dimensional, where you have this continuous improvement and scalability, you have the integration point of view, but then you have the actual life cycle of how you deliver your solutions to the customer. And this is something PLM needs to take a look, understand that complex solutions are built of different pieces, and to get there, you need certain type of pre-delivery, delivery, and post-delivery services to maintain this. I have a few more slides. I won't go into this in detail, you get this. The basic idea here is PLM is trying to build the architecture of understanding what is the relationship, as an example here, if you have equipment, that how equipment relate to processes. That can be, for instance, a grinding process. And then how does this grinding processes or all processes relate to a big solution like a mineral processing plant or a paper mill? So there's certain equipment, certain processes, and combining them, you have a plant. And then for each of these, you could say physical artifacts, you have then services. Some of them are pointing towards the equipment, some of them are pointing towards the processes, some of them are pointing to the overall plant in this case. And the third element here is then the system of software. How do you maintain this? That you have equipment level software and systems that are there, digital capabilities, then you have at the process level, and then you have at the plant level. And this gives you the basic framework to understand what you can offer to the customers. But then you have the decision of what are the business applications that you want to apply this framework to. One is to look at it from, a good example is you make the decision that you only work in copper or non-radioactive materials. That is a business application of this products that you have. And then based on that, you can have the customer association, what type of customers you're getting to. And this brings you back to your business model where the customer, the product are tied together, and you start to understand the value proposition. just check time. Yeah, okay. Just looking at this slide, what I'm trying to highlight here really is that the traditional way of looking at PLM has been that we've understood that we can manage products from a requirement point of view, requirement structures, functional structures, what is the functions that the product does, the logical structure, every single house has foundations, walls, windows, and a ceiling, and then the physical structures, and they are the actual doors that you can go out and buy. And the nails that you use to build the house, and the cement that you use on the foundation, and they define the traditional structure of a product. But now today, this information flow is important. But then when you build the simulation elements on it, you can actually start to build a real digital twin and define it for a physical product, but also for services. And then you can actually build this product service system that is a digital twin. And the digital twin should not be static, it should be living. Once this is understood, you can start to figure out that, hey, we can actually open this out and collect data and push data. And you can use, this is just an example, IoT platforms, and you can create digital services and offer them to customers. And this enables, once the real product is in existence and at a customer, you can connect the physical system to the digital system, and then you can start to exchange data and information in both directions. Time-wise, we're probably a little bit pressed. This slide, I'll just quick highlight from here is that product maturity. Complex systems at the extreme is engineering to order. You just know that you'll deliver a lithium plant, battery plant, but you don't know how. You've never delivered it before, but you know the technologies and the design processes needed for it. So you design it for Tesla from scratch. The other alternative is that you have good configurations that you can use, but you still need to do the final design to deliver it to the customer for their customer needs. And then once it's in operations, you need to maintain it regardless of how you deliver it or your design philosophy is. So you need to maintain it and make sure that the customer need and performance values are met. And then the final one is this, that you can always improve it by extending the processes. This one I won't go through, but the basic point really here is that there's two ways of looking at it. The service recipient who is getting the services, and the other one is the nature of the value proposition. And you can look at it, it can be totally based on the asset. So it's always on the for instance, the aircraft company's engine. You look at it always through the engine. So you deliver spare parts, services around that, or you guarantee an asset's performance. The other alternative is to understand the customer's processes that he's using, what he actually does in his daily business, and you offer through that product support services like diagnostics of welding processes, or as an example. The highest level of this area is the total delegation of the services, where the actual company delivering isn't anymore selling the product as such, but they're running it completely, and they may even maintain ownership of it. So fly-by-hour agreement for commercial jet lines is an example of that. This I'll jump from, but briefly through. So digital twin and PLM. So the digital twin we spoke about earlier is actually a certain instance that is managed through the product's lifecycle. And from our point of view is that product lifecycle management should not look at static structures. It should have a real digital twin that works like the real one, that is connected to the physical world's counterpart. The digital thread is any single instance throughout this development life cycle. So the digital thread is all the aircraft delivered, but all of the design product lifecycle information that is collected over the life cycle of that product program or that particular instance. And just to highlight, just to finish off, at the end of the day, and I agree to this statement that whoever can gather and manage product information will excel or not be in business for long, depending on if they can do this. And I think this is true when it was written originally, but it's even more important today. But if you understand the product information and you can utilize it and you can collect it, then you can build really interesting new customer experiences and services around it. Okay, I think that sums it up as a quick introduction to product lifecycle management. And I think I'm a little bit over time. Yeah. Yeah. From my point of view, if there's any questions, I don't mind going over time, but it's up to participants.
I have one more question.
Yes.
Since right at the moment, sustainability is getting more important, and I was wondering your opinion and how life cycle, how the customer can understand better the life cycle, and if there's a possibility in the future to offer to the customers a better view of the life cycle of each product. Because, for example, I don't know, right now electric cars are getting momentum, but sometimes it's difficult for the customer to understand if you're really buying something that is helping the environment, and also for the food and for different products. I would like to understand your opinion about that.
What I've seen is the companies are building this life cycle value calculation capabilities, so they can prove, or they try to prove to the customers that if you invest in this type of solution, this is the life cycle the product will have, and this is how much you will save, for instance, in water usage or power usage, and they can show the services over a life cycle. This is projected what is. Obviously, every product comes to an end of life, and one of the things that PLM has always been advocating is also the end of life. What do we do when a product or a component of a product gets to the end of life? And this is why these shutdown services, for instance, in certain industries, have become they're being offered. So a product comes to a certain, or a plant comes to a certain life cycle, then there's a clear process or service that is offered that to shut down that plant in a systematic way. So it's basically taken to parts, and then the reusable parts can be reintroduced to other existing plants, for instance, a mine or a mineral processing plant or a paper mill, and they continue their life there. And then there's also the other areas that can be then recycled. This has been the vision, or the problem has been this connection of understanding what is actually happening at the customer site, and collecting the data and simulating the data and telling the customer when to upgrade or when to reduce, or if the business case drops out, how do we then dismantle a complex system and then use the good elements in other areas? So we reuse them, and what we scrap and how do we scrap it? So it's been in the vision always, but part of collecting that data, having the insight into how the customers operate their solutions has been a challenge. But by having this digitalization, having a digital twin, and being able to simulate this, the life cycle scenarios is now becoming a reality, and companies are collecting this data and trying to offer this. Did I answer your question?
Yeah, yes, thank you.
Any other questions? Okay, but I mean, if there are any questions come up, you can send me an email and I'll try to answer. But my vision or goal is to spread the PLM message to as many people as possible, because it's so important, and it's changing today in business. Yeah, I mean, for me, it was, I just quickly, and my professor, when I was looking for a thesis, he said, hey, we have an aircraft program going on. Would you be interested to take a look at this, how we manage the product design data? And that's really what put me on this road.
I have one question real quick, and it's more about the actual software being used in PMO systems. What's your actual opinion on the software being used, as the experience that I've had and what I've heard from other people is that the PMO systems are often very cumbersome to use. And what is your, how would you see their implementation in a manner that it doesn't slow down the actual development of products and the maintenance of products?
You have hit a really, really interesting topic here. PLM systems, I started working with them before, in the last decade, we can say it like this, and they were terrible. I mean, they were really bad. They were not user-friendly. User experiences was everything else but an experience. But they've got better, but still today, one of the main issues is that they are cumbersome. They've done, if I think about Enovia, I've worked with Enovia, I've worked with Team Center, I've worked with Oracle's equivalent. They are complex systems, and they're not the most user-friendly. But the problem many times is that the companies who are implementing them start from buying software, and they don't build an overall PLM vision, what the PLM vision is. And PLM should not only look at just one design organization corner or the design of the product. It needs to look at the complete process and understand how those processes can be made more efficient over the complete life cycle. Some departments will gain, some departments will not gain. They will have a little bit more work, or have more work to do. But PLM should be really a concept of the business processes, the information architecture, the organizational structure, and the software that is needed. So if I take PLM as an example, and you take Enovia, from Dassault Systems is focused on systems engineering logic. If your company doesn't assign to systems engineering, then you have a problem. If you have a different way of doing business. So most failed PLM projects have been due to the fact of buying the software without really understanding the complete PLM concept.
Yeah, thank you. So another real quick here is that if I understood correctly, you think that the PML software that a company uses should change according to the company's vision and the company's needs, and the company should not change according to the software's needs.
I think there's a balance there that I think as an extreme is that if a company is clearly seeing that they need to go to a systems engineering direction, as an example, they should not change that software to their vision. They should leverage what the software offers. So basically, what I'm trying to say here is that just replacing the way you're working today with a new PLM system is okay, one way to do it. But if you want to transform the business, then it's also good to understand the direction that your business is going in, how your products and services will change, and then select a PLM system that can support that, but also has already certain built-in capabilities that you're looking for. I probably explained this too complicatedly, but I'm not sure. Did you?
Oh, I got it.
Okay.
That's a good explanation. Thank you.
So that's why when you talk about PLM and implementing PLM, the first question is that are you changing software or are you doing a business transformation? If it's software change, then it's a totally different thing to have to do business transformation. But PLM starts from the business. That's the point of it. It tries to join together the product and everybody around the product over the life cycle, the company, suppliers, and then also the customer. And then you have the integration to the other systems. So it's not one system. Any of it has to integrate to the design systems, to the ERPs, the CPQs that you have, the CRMs, and then you will obviously want to be able to connect to the data analytics side of it. Okay, any other questions? It would seem not. Yeah. I would actually love to, if I can join, could you, if it's okay, I would like to come and listen, if you don't mind sending me the invitation, I would be very interested to hear. Okay. Okay, thanks. Hey, that would be, yeah, it would be interesting because you've spoken about this a few times, the bicycle dynamics and simulation. Yeah. Thank you, everybody. Bye.
Thank you for presentation. Bye.
Thank you.
Thank you.
Thank you.
Bye.
Bye.
Bye.